Oh, you filthy swines! Get in here, sit down. We're going to do this. We're going to read some news. The debate as to whether we live in a simulation or a creation, in my mind, those two concepts are pretty much the same thing. If you ask people, they will have different opinions on what these things mean, but effectively, is the universe that we are in a created thing, or is it not? In my opinion, it is. I think there are creative forces in the universe. And I think pretending that they don't exist just makes it even more difficult for us to interpret what goes on in the world around us. I think we have to entertain the fact that there are creative forces. Otherwise, we're blinkering ourselves. Anyway, following along that trajectory of thought, this article on the Lad Bible, written by Dan Seddon, AI expert, explains why he is very close to certainty that we are currently living in a simulation. Dr. Roman Yampolsky revealed on Stephen Bartlett's popular podcast. Existence as we know it is almost certainly a simulated design, according to a renowned Latvian computer scientist and AI maestro. Founder of Cybersecurity Lab at the University of Louisville, Dr. Roman Yampolsky joined podcaster and entrepreneur Stephen Bartlett on the Diary of a CEO last week. During their brain-bruising discussion, which ran close to 90 minutes in length, the podcast guest came to the table with several revelations, including his belief that humankind is already so entrenched in technological lives that we're essentially living in a simulation. That's child's play, literally, in his mind, though. The deeper suggestion is all to do with the species of future humans who've conquered technology playing with their toys. Interesting. Yampolsky was responding to Bartlett's reference to Google's Genie 3, which allows users to generate a whole world from just one picture. You can move through the world or put it on a screen for people to see, explained the podcaster. Google have released this technology that allows you, with a simple prompt, to make a three-dimensional world that you can then navigate through. And in that world, it has memory. So if you paint on a wall and turn away, you look back and it's persistent. When I look at that, I go, bloody hell. This is like the foothills of being able to create a simulation that's indistinguishable from everything I see here. Yeah, but in reality, have you not looked at the video game industry for the past few decades? Smiling, the bearded AI expert chirped in with, right, that's why I think we're in a simulation. That's exactly the reason. AI is getting to the level of creating human agents, human revelations, and virtual reality is getting to the level of being indistinguishable from ours. Bartlett, who famously went from scavenging pizzas as a university dropout to earning $10,000 an hour, went on to question Yampolsky about the first principles of his theory. He's an interesting guy, this Stephen Bartlett guy. His podcast series I need to check out more often. He's pretty cool. We're definitely running a lot of simulations for research, for entertainment, for games, all sorts of reasons. And the number of those greatly exceeds the number of real worlds we're in. Look at the video games kids are playing. Every kid plays 10 different games. A billion kids in the world, so there's 10 billion simulations and one real world, he said. That's an interesting way of putting it, yeah. Even more so, when we think about advanced AI super intelligent systems, their thinking is not like ours. They think in a lot more detail. They run experiments. So running a detailed simulation of some problem at a level of creating artificial humans and simulating the whole planet would be something they do routinely. It's the future simulation thinking about something in this world. Anyone else's head aching now? Well, that was a short article, so we're going to move on to the next one, which is in a similar vein. And it's true. I mean, if you're able to create simulations off the cuff at our current level of sophistication, then give it another decade, and I don't think there's going to be any debate that we'll be able to create completely convincing simulations of the world from a human perspective. Our second article on Scientific America, written by Ananthaswamy and also edited by somebody called Lee Billings. Well done, sir. Do we live in a simulation? Chances are 50-50. Gauging whether or not we dwell inside someone else's computer may come down to advanced AI research or measurements at the frontiers of cosmology. It's not often that a comedian gives an astrophysicist goosebumps when discussing the laws of physics. But comic Chuck Nice managed to do just that in a recent episode of the podcast Star Talk. The show's host, Neil deGrasse Tyson, had just explained the simulation argument, the idea we could be virtual beings living in a computer simulation. If so, the simulation would most likely create perceptions of a reality on demand rather than simulate all of reality all the time, much like a video game optimized to render only the parts of a scene visible to the player. It's much more efficient that way. Yeah, if you're only interested in the perception of the simulated world, then why render the things that aren't being perceived? Which is also, interestingly, in line with the current understanding of quantum mechanics. Maybe that's why we can't travel faster than the speed of light, because if we could, we'd be able to go to another galaxy, said Nice, the show's co-host, prompting Tyson to gleefully interrupt before they can program it. The astrophysicist said, delighted at the thought, so the programmer put in that limit. Well, it's a clock rate, isn't it, the speed of light? Can't go faster than that. Such conversations may seem flippant, but ever since Nick Bostrom of the University of Oxford wrote a seminal paper about the simulation argument in 2003, philosophers, physicists, technologists, and yes, comedians and pigmen have been grappling with the idea of our reality being a simulacrum. Some have tried to identify ways in which we can discern if we are simulated beings. Others have attempted to calculate the chance of us being virtual entities. Now, a new analysis shows that the odds that we are living in base reality, meaning an existence that is not simulated, are pretty much even. But the study also demonstrates that if humans were ever to develop the ability to simulate conscious beings, the chances would overwhelmingly tilt in favor of us too, being virtual denizens inside someone else's computer. And caveat to that conclusion is that there is little agreement about what the term consciousness means, let alone how one might go about simulating it. In 2003, Bostrom imagined a technologically adept civilization that possesses immense computing power and needs a fraction of that power to simulate new realities with conscious beings in them. Given this scenario, his simulation argument showed that at least one proposition in the following trilemma must be true. First, humans must always go extinct before reaching the simulation savvy stage. Second, even if humans make it to that stage, they are unlikely to be interested in simulating their own ancestral past. And third, the probability that we are living in a simulation is close to 1. Before Bostrom, the movie The Matrix had already done its part to popularize the notion of simulated realities, and the idea has deep roots in Western and Eastern philosophical traditions, from Plato's cave allegory to Zhang Zu's butterfly dream. More recently, Elon Musk gave further fuel to the concept that our reality is a simulation. The odds that we are in base reality is 1 in billions, he said in a 2016 conference. We're immersing ourselves more and more in simulations, or at least I am, with video games and such, and they're extremely popular. So whether or not our experience is itself a simulation, we are dipping ourselves into simulations. And it seems only a matter of time before they become complex enough that consciousness can potentially exist in them. Musk is right if you assume propositions 1 and 2 of the trilemma are false, says astronomer David Kipping of Columbia University. How can you assume that? To get a better handle on Bostrom's simulation argument, Kipping decided to resort to Bayesian reasoning. This type of analysis uses Bayes' theorem, named after Thomas Bayes, an 18th century English statistician and minister. Bayesian analysis allows one to calculate the odds of something happening, called the posterior probability, by first making assumptions about the thing being analyzed, assigning it a prior probability. Kipping began by turning the trilemma into a dilemma. He collapsed propositions 1 and 2 into a single statement because in both cases the final outcome is that there are no simulations. Thus, the dilemma pits a physical hypothesis, there are no simulations, against the simulation hypothesis. There is a base reality and there are simulations too. You just assign a prior probability to each of these models, Kipping said. We just assume the principle of indifference, which is the default assumption when you don't have any data or leanings either way. The one interesting thing that I have considered. We talk often about there being a base reality, but is it not possible that there is no base reality, and that the further you look outside of the box of this simulation, you'd find another simulation, and that could effectively go on forever? Why does there have to be a base reality? I know it seems like an irrational thing to say, but is it possible that simulations could evolve through random fluctuations in some system somewhere? Because if you look at the idea of cellular automata, specifically there's a thing called the game of life, which is a very small set of rules on how a series of patterns can evolve over time. From having a very small set of rules, you can evolve a very complex pattern of potentially self-sustaining entities or cellular automata. So I'm curious, is it possible that a simulation could itself evolve from much smaller origins? So each hypothesis gets a prior probability of 1/2, much as if one were to flip a coin to decide a wager. The next stage of the analysis requires thinking about the porous realities, those that can generate other realities, and null porous realities, those that cannot simulate offspring realities. If the physical hypothesis was true, then the probability that we are living in a null porous universe would be easy to calculate. It would be 100%. Kipping then showed that even in the simulation hypothesis, most of the simulated realities would be null porous. That is because as simulations spawn more simulations, the computing resources available to each subsequent generation dwindles to the point where the vast majority of realities will be those that do not have the computing power necessary to simulate offspring realities that are capable of hosting conscious beings. Right, except I don't personally agree with that. I think you could say that child universes simulated by a parent-based reality would have a slower clock rate, but internal to their own experience, that is irrelevant. So just like in the movie Inception, when you have a dream inside of a dream inside of a dream, each nested Russian doll of a dream runs slower than the external one. Simulations may slow down as they're nested, but that doesn't necessarily mean that internal to the subjective experience of that simulation, that it wouldn't be a full-fleshed experience. Plug all of these into a Bayesian formula and out comes the answer. The posterior probability that we are living in base reality is almost the same as the posterior probability that we are in a simulation, with the odds tilting in favor of base reality just by a smidgen. These probabilities would change dramatically if humans created a simulation with conscious beings inside it, because such an event would change the chances that we previously assigned to the physical hypothesis. You can just exclude that hypothesis right off the bat. Then you are only left with the simulation hypothesis. Kipping says, the day we invent the technology, it flips the odds from a little bit better than 50-50 that we are real to almost certainly we are not real, according to these calculations. It'd be a very strange celebration of our genius that day. It's a very strange assumption that if you're entertaining the idea of being in a simulation, that you are also simultaneously incapable of appreciating the idea that that simulation is a creation, and that perhaps people have been going on about this for thousands of years. Maybe. I don't know. Could you entertain that, maybe? The upshot of Kipping's analysis is that given current evidence, Musk is wrong about the 1 in a billion odds that he ascribes to us living in base reality. Well, Musk is his opinion. I think I agree with it, although I'm not entirely convinced that there has to be a base reality, which sounds absurd, but I'm not exactly sure it makes sense to assume there is a base reality. Everything is relative, in my opinion. Bostrom agrees with the result, with some caveats. This does not conflict with the simulation argument, which only asserts something about the disjunction. The idea that one of the 3 propositions of the trilemma is true, he says, but Bostrom takes issue with Kipping's choice to assign equal prior probabilities to the physical and simulation hypothesis at the start of the analysis. The invocation of the principle of indifference here is rather shaky, he says. One could equally well invoke it over my original 3 alternatives, which would then give them 1/3 chance each. Or one could carve up the probability space in some other manner and get any result one wishes. Such quibbles are valid because there is no evidence to back one claim over the others. That situation would change if we can find evidence of a simulation. So could you detect a glitch in the matrix? Hooman Al-Hadi, an expert on computational mathematics at the California Institute of Technology, has thought about the question. If the simulation has infinite computing power, there is no way you're going to see that you're living in a virtual reality because it could compute whatever you want to the degree of realism you want, he says. If this thing can be detected, you have to start from the principle that it has limited computational resources. Think again of video games, many of which rely on clever programming to minimize the computation required to construct a virtual world. From Al-Hadi, the most promising way to look for potential paradoxes created by such computing shortcuts is through quantum physics experiments. Quantum systems can exist in a superposition of states, and this superposition is described by a mathematical abstraction called the wave function. In standard quantum mechanics, the act of observing causes this wave function to randomly collapse to one of many possible states. Physicists are divided over whether the process of collapsing is something real or just reflects a change in our knowledge about the system. If it is just a pure simulation, there is no collapse. Awadi says everything is decided when you look at it. The rest is just a simulation, like when you're playing these video games. To this end, Awadi and his colleagues have worked on 5 conceptual variations of the double-slit experiment, each designed to trip up a simulation. But he acknowledges that it is impossible to know at this stage if such experiments could work. Those 5 experiments are just conjectures, Awadi said. In my opinion, is every eventuality is explored. Your subjective perspective is just one facet of a multitude of perceptions that propagate exponentially outwards. I think time is multidimensional, and your personal linear memory of it is only a path, a straight line through that potential. Similar to how light moves in straight lines, but actually I think on a quantum level travels every potential route. Zohre Davodi, a physicist at the University of Maryland College Park, has also entertained the idea that a simulation with finite computing resources could reveal itself. Her work focuses on strong interactions with a strong nuclear force, one of nature's 4 fundamental forces. The equations describing strong interactions which hold together quarks to form protons and neutrons are so complex that they cannot be solved analytically. To understand strong interactions, physicists are forced to do numerical simulations, and unlike any supercivilization possessing limitless computing power, they must rely on shortcuts to make those simulations computationally viable, usually by considering space-time to be discrete rather than continuous. The most advanced result researchers have managed to coax from this approach so far is a simulation of a single nucleus of helium that is composed of 2 protons and 2 neutrons. Naturally, you start to ask, if you simulated an atomic nucleus today, maybe in 10 years, we could do a larger nucleus maybe in 20 to 30 years. We could do a molecule, Dowdy says, in 50 years. Who knows, maybe you could do something the size of a few inches of matter. Maybe in 100 years or so, we could do the human brain. I think it's much sooner than that. I think you're placing too much emphasis on calculating things down to an atomic level. And I don't think that necessarily maps on to our perception of reality. I mean, I can't see atoms with my eyes. Can you? Dowdy thinks that classical computers will soon hit a wall, however. In the next maybe 10 to 20 years, we will actually see the limit of our classical simulations of the physical system, she says. Thus, she is turning her sights to quantum computation, which relies on superpositions and other quantum effects to make tractable certain computational problems that would be impossible through classical approaches. If quantum computing actually materializes in the sense that it's a large-scale, reliable computing option for us, then we're going to enter a completely different era of simulation, Vivaldi says. I'm starting to think about how to perform my simulations of strong interaction physics and atomic nuclei if I had a quantum computer that was viable. All of these factors have led Vivaldi to speculate about the simulation hypothesis. If our reality is a simulation, then the simulator is likely also discretizing space-time to save on computing resources, assuming, of course, that it is using the same mechanics as our physics for that simulation. Well, don't we have the Planck width as the smallest discrete size of the universe? So is that not already down on that level? Signatures of such discrete space-time could potentially be seen in the directions high-energy cosmic rays arrive from. They would have a preferred direction in the sky because of the breaking of so-called rotational symmetry. Telescopes haven't observed any deviation from the rotational invariance yet, Devaldi says, and even if such an effect were to be seen, it would not constitute unequivocal evidence that we live in a simulation. Space reality itself could have similar properties. Kipping, despite his own study, worries that further work on the simulation hypothesis is on thin ice. It's arguably not testable as to whether we live in a simulation or not, he says. If it's not falsifiable, then how can you claim it's really science? For him, there's a more obvious answer. Occam's razor, which says that in the absence of other evidence, the simplest explanation is more likely to be correct. The simulation hypothesis is elaborate, presuming realities nested upon realities as well as simulated entities that can never tell that they are inside a simulation. Because it is such an overly complicated, elaborate model in the first place, by Occam's razor, it really should be disfavored compared to the simple natural explanation. Kipping says, maybe we are living in base reality after all, the Matrix, Musk, and weird quantum physics notwithstanding. It's a fascinating subject, and yeah, I mean, it's going to be hard to prove it otherwise. There are interesting parallels between simulated systems that we're creating, and we were already creating simulations. So if the question is, if we can create simulations that then increases the likelihood that we're in a simulation, perhaps we haven't officially created a conscious being in a simulation yet, but we are clearly creating simulations and they are increasing in complexity. So it seems as if we're heading in that direction. And one thing that would definitely bust this apart is if it were ever possible to send information backwards in time, if tachyons actually existed, you could do computational processes and send results backwards in time. The most complicated simulations could be split apart into much more discrete chunks. So in a situation like that where time itself isn't a restriction, then you could effectively simulate anything with infinite fidelity. So currently, not popularly seen as being possible. If you entertain that idea, that maybe time travel is in some way possible, if it is, then we could create simulations that have infinite fidelity, and that would be quite interesting. It's an understatement there. But even if we can't do that, then I think it's weird to assume that just because you're creating a simulation that is going to be running at a slower clock rate than your personal base reality doesn't mean that that simulation itself, internal to its own experience, is in some way degraded. I don't think that makes sense at all. But there we go. I think we're in a simulation, in a creation. I think there's a lot of evidence to show that that is highly likely. People have been talking about this for thousands of years. We just choose to quarantine the idea of creation away from science, but I don't think that makes sense at all. People choose to throw the word simulation around and feel as if they are being more scientific and credible in saying that. But it is effectively a creation. But my opinion is also that the words that we are choosing to use here describe more about us than about the nature of reality, and they're used to separate people. So I'll use the word simulation and creation interchangeably, and creative forces to refer to God or any creative force that isn't humanity. So I'm very open to all of this, and I think it's fascinating. But that is it for now. Make sure you hit that like button. Subscribe if you like what I do. I do it as often as I can. But the only thing I have left to say now is Pigwig out.
Oink, oinkity, snort, snuffle, snuffle, squee, oink, oink, wee, squeal, snort, snort, oink, kitty, squee. Oink, 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 squee, squee, wee, 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 snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 wee, 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 oh. Snort, snuffle, oink, squee, squeal, wee, snort, oinky, oinkity, oink, oink, snuffle, wee, squee, snort, oink, squeal. Oink, 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 squee, squee, Snuffle, snuffle, squee. Oinkity, oink, oink. Snuffle, re-squeeze, snort, oink, squeal. Oink, oink, oinkity. Squee, squee, re. Snuffle, snort, squeal, squeal. Oinkity, oink, snort, snort, squee. Oink, 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 oink. Re. Squeal, squeal. Snort, snuffle, oink, re-squeal, re-snort, oinky, oinkity, oink, 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 snuffle, re-squeeze, snort, oink, squeal, oink, oink, oinkity, squeeze, squee, re, snuffle, snort, squeal, squeal, oinky, oink, snort, snort, squee, oink, 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 oink.